So question 5, which Miriam and Anila, I will get you back, but I'll just do that one. So you have this position function, sine t, cosine t. And at this point, you're kind of familiar with what is going on here. If x of t is sine and y of t is cosine, okay, I'm going to start at, let's see, at t is equal to 0. So in other words, s of 0, the position of this vector, when t is equal to 0 is going to be 0, and cosine of 0 is 1. So what I know is that we're going to start up at 0, 1. And then if I was going to proceed around, what I know is going to happen is that as t increases, well, we know what sine looks like, right? We know x of t, sine is going to increase. So my x value is going to increase to 1, and then decrease to 0, and then decrease to -1, and then increase. So I'm going to be going in this direction, increasing to 1, decreasing to 0, decreasing to -1, and then right back at the start. And the other thing I know to confirm that is y is cosine. So my y value starts up at 1, but then decreases to 0. So I'm, again, going in this direction. Y is 0, and then y descends to -1, and then it's 0 again, and then y goes back up to 0. So this is what I would imagine this looks like. It's confirmed by the fact that you know that sine squared of t plus cosine squared of t is a Pythagorean identity equals 1, which gives us x squared plus y squared is equal to 1, which of course is the equation for a circle with center at the origin and radius 1, which is exactly what we have. Okay, for part B, we need to find the velocity vector. And you know that the velocity vector is just going to be the derivative of our x component and y component. So that's going to give us the derivative of sine is cosine. The derivative of cosine is negative sine. And then we need to find the velocity at pi over 4, at t is equal to pi over 4, okay, which gives us, let's see, cosine of pi over 4 is 1 over root 2. Negative sine is -1 over root 2. Okay. Velocity at 3 pi over 4 is going to give us kind of the same thing. You know, cosine of 3 pi over 4 is -1 over root 2. Sine is +1 over root 2. And that makes a little bit of sense. At pi over 4, so this is where t is 0. This is where t is pi over 2. So at pi over 4, we are right here on our circle. And we're heading in this direction, so you know that the x is increasing, the y is decreasing. At 3 pi over 4, we're right about here, heading in this direction, so we know that our x value is decreasing, and our y value is also decreasing, because that's negative sine. Okay, what about the speed of the particle? We had said that the speed of any particle is, we just need to take away sort of the direction. The speed then is going to be the magnitude of the velocity vector. So if I look for the speed at pi over 4, well, that's going to be the square root of 1/2 plus 1/2, which is the square root of 1, which is 1. And notice I'm going to get the very same thing. So the speed at 3 pi over 4, in fact, is also going to give us 1, which is a little suspicious. So then for part D, so this was C, for part D, we are asked if we can assume that the particle travels at constant speed. Well, in fact, of course we can, because our velocity magnitude is always going to be the square root of our x component squared and our y component squared. That negative is going to go away. So in fact, we're traveling with a constant velocity of 1 around this unit circle. And then finally, for the last part, we're looking for the slope at t is equal to pi over 4. And what we had said is that slope, so dy dx, is just going to be dy dt over dx dt. So at pi over 4, I'm just going to have -1 over root 2 over 1 over root 2, which in fact is 1. -1, which makes sense because it definitely looks like the slope of that line is -1. And at t is equal to 3 pi over 4, same thing, dy dx is going to be -1 over root 2 over -1 over root 2, which is going to give us 1. And again, we're located right at this point, so the slope of that line definitely is 1.